what we want to do now is go through an example of how to identify the part that the customer comes in the store with. So if you'll turn to page 10 and 11 in the catalog, what you'll see on page 10 toward the bottom is you'll see all the domestic shapes, or North American parts that are made in North America are domestic shapes. Round, rectangle, square, and hex are going to be the shafting, and the tubing is going to be round, rectangle, or square. If you look over on the top of page 11, what you're going to see is the metric shapes. The metric shapes look like this. You have the lemon shape for the German metric, or it could be the star shape for the German metric. And then on the Italian metric, what we have is the trilobe. So when you look at these three parts right there, you'll be able to tell them easily from the square and rectangular of the domestic. One of the things that we want to do is go through an example. Let's just say the customer comes in and he has this tube right here, which is square. And so if it's actually rectangle, if it's rectangle, what we know is this is going to be a domestic shaft. So what we're going to do is we're going to take the domestic transparency. These are the transparency ID systems. All they are is a measuring system. If you're using a mic and a caliper, you're still welcome to use it. What we do have in the back of these though, for instance, the domestic, we have all the shapes drawn. We have the rounds, the squares, the spline shafting, the rectangular, and the solid shafting is all drawn in the back of these. And you can see each one of them in there. And then in the metric, what we do is we have all the profile tubing drawn in there. The star and the lemon shape, and then also the trilobe shapes are all drawn in there. So it makes it very easy to set on top of the shaft and tell exactly which part it is. So let's just say we're looking at this one. We know it's a rectangle, so it's going to be in the domestic book right here. And the customer usually comes in the store with a part. Let's just say they came in with this part right here. What we're going to do is we're going to measure this part using the Weasler Transparency ID system. So when we turn over in it, these are all in ascending order. And what we're going to see, a lot of these may have two sizes drawn on here. And so what we're going to do is we're going to place the hole here over the hole in the part and check and see. That one there looks right on to me. This one here is pretty close. But we also draw the ears on here. So when we put it behind here, you see this one comes up a little bit short. So when we go up here, this one comes up exactly. And what this tells us is on domestic, we only need to know one number. And this gives us a number we need to know, which is 1 1/16 inch. At this being 1 1/16 inch, if we turn to go to page 9 in the catalog, and on page 9 we have every series listed that we make. The top 1/3 of the page is the North American or the domestic parts. Then you have the Italian metric, and then below that the German metric. So we know we're working on the domestic part, we're going to be on the top 1/3. So this is 1 1/16 inch hole. You go right over to the bearing diameter column, and you drop down till you find 1 1/16 inch. When you find that, what you're going to do is you're going to go right across over to the left, and it's going to tell you that the part number of that cross kit is a 200-1200. And then we're going to come straight back across. The third column over is going to tell us that's a 12 series. And then when we go all the way over to the right, it says turn to page 49. So when we turn to page 49, what we see at the top of page 49 is the most typical use of that shaft drawn. And you see at the top it says it's a 12 series, and right up under it says it's a 1 1/16 inch hole size, which is an identifying mark for that series. So what we're going to do at that point, we've narrowed our search in that one step by measuring, going to page 9 and coming back. We've narrowed our search from the whole world down to 5 pages. So the tractor starts off first. We always go from the tractor to the implement. The merchandise is laid out from tractor to implement. The shaft is laid out from tractor to implement. And the catalog is laid out from tractor to implement. So what we want to do is show the shaft drawn to our customer and just let them pick out the broken part. If they say it's the tractor yoke and the U-joint, it would be as simple as picking these two parts up right here, which, like we told you earlier, they're color-coded, green and green, and they'll be gone. If you need more parts, you just go right down the shaft. All it is a power circuit with the power being transmitted from the tractor to the implement, and all we're doing is replacing the broken part. So our job is just that simple. And I want to go through the numbering system on the shaft real quick, just to reinforce what we've already told you. First of all, this is laid out. I have these parts laid out just like a shaft. And what we have is we have a tractor yoke is first. We know that this is an 1 1/16 hole because we measured it. So we have a tractor yoke. A tractor yoke is always a 100. Because it has a thumb pin, it makes it a 102. The hole size is an 1 1/16, which makes it a 12 series. And the bottom hole on this happens to be 6 spline or 06. So the part number is 102 12 06. If it was a 21 spline, it'd be a 102 12 21. That's how the tractor yoke's done. The U-joints are the same on both sides. Again, 12 series because this is an 1 1/16. So we have a 200, 1200. We have two of those. The two inboard yokes are basically identical. They have a bearing race that the bearing runs on exactly like this right here. Nylon bearing sets on there and it turns with a shield. These two yokes are identical with a bearing race except for the hole size. The shaft is always smaller, so the hole in this one is smaller, so this would be the shaft yoke. It's the first one as we go down the shaft, so it's a 300, 1200. This is a tube weld yoke. It's larger, so the tube goes in it, so this would be a 700, 1200, the tube weld yoke. The variation always comes in on the implement end. On the implement end, we have all different sizes. The bottom hole on the implement end is always measured in 16ths. For instance, this is an 800 implement yoke. We're going right down the shaft. 800 is an implement yoke. Happens to have a double keyway. Because it has a double keyway, it makes it an 806. You're only going to use one at a time because they're two different sizes. So 806, the hole size here is an 1 1/16, which makes it a 12 series. And the hole in the bottom is 1 inch or 16/16. So 806, 12, 16. We have people that call us every day and ask for a 806, 12, 21. And what they're doing is they're building a number in their head, and that's how they figure out exactly what they're looking for. And that's the way you identify a Weasler part. If you forget any of this, go back to page 40. It gives the examples for every series.